Okay, think about this for a second. There's this piece of tech born way back in 1995 that is pretty much running our entire modern world, just quietly in the background. We're talking about Java. And in this explainer, we're going to figure out why this language, which is almost 30 years old, is more important right now than it's ever been. Let's get into it.
And that's the big question, right? In the world of tech, things can feel like ancient history in like a year. So how in the world has Java stayed at the top of the mountain for decades? It's everywhere, from stock markets and banks to the Android apps on your phone. So what's its secret sauce?
To really get why Java was such a game changer, we've got to hop in our time machine. We're going back to the early 90s to look at a massive headache that every single developer had to deal with, the platform problem.
I mean, just try to picture this. You pour your heart and soul into writing some amazing software, but it only works on one specific type of computer. You want it to run on a Mac? Sorry, you got to start over. A complete and total rewrite. For a Linux machine? Yep, do it all again. It was a nightmare. Your code was basically chained to the operating system it was built for, and it was just so inefficient.
And this, right here, shows you the problem and the solution in a nutshell. The old way, with languages like C++, was like forging a key that only fits one single door. You'd compile your code and get, say, a windows.exe file. That key is totally useless on a Mac. But Java came along with this radical new idea. What if we created a master key, a universal file that isn't for Windows or Mac, but for everywhere?
And that brings us to Java's big aha moment. Its solution was so clever, so revolutionary, that it really did feel like a magic trick. And it's a trick that completely reshaped how we built software forever.
So what's the secret ingredient behind this magic? It's a little thing called bytecode. Now, this isn't the normal machine code that a computer chip can understand directly. Nope. Think of it more like a universal blueprint. It's that special .class file we just mentioned, an intermediate language that can be read by a special kind of interpreter. Okay, so how does this actually work? It's really a beautiful three-step dance. First, a developer writes their Java code. Then the Java compiler takes that code and turns it into that universal blueprint, the bytecode. And then for the final step, a special piece of software that's already on your device, called the Java Virtual Machine or JVM, steps in. It acts like a translator, reading the blueprint and telling your specific device exactly what to do in its own native language.
And boom, this is the payoff. You write the program one time, you compile it into that single bytecode file, and then that same exact file can be run on a desktop, a server, a phone, you name it. As long as that device has its own JVM translator, the code just works. This became Java's famous mantra, write once, run anywhere.
All right, so let's really nail down what this JVM thing is. The universal translator analogy is perfect. It's a program that lives on each machine and knows how to speak two languages, the universal language of Java bytecode, and the local language of whatever operating system it's on, like Windows or Mac OS. And here's the beautiful paradox. The Java code is universal, but the JVM itself has to be specific to each machine. It's that local translator that makes the code truly global. Kind of brilliant, right?
Now, don't think for a second that Java just dropped this bombshell and then went on vacation. No way. It has been constantly evolving. Pretty early on, it got things like the collections framework to help manage data. A few years later, generics came along to make code way safer, and this never stopped. It continues all the way up to today, with brand new features like virtual threads and Java 21, which are designed to make modern apps run incredibly fast. The big takeaway here is that Java never, ever stood still.
Okay, so we've got the history. We get the magic trick, but how does that old idea of platform independence make Java an absolute monster in today's tech world?
First on the list, cloud computing. What is the cloud, really? It's just a giant, sprawling network of thousands of different computers, running all sorts of different hardware and operating systems. See where this is going? Java's whole run-anywhere philosophy is basically the cloud's dream come true.
Yeah, this quote really hits the nail on the head. Java was essentially designed from the ground up for this kind of distributed work. It's built to handle huge, complex systems spread out across the network, which is, well, that's exactly what a modern cloud application is. It was practically born for this.
All right, next up is another huge trend, microservices. The old way was to build one gigantic, complex application, kind of like one huge Jenga tower. The modern way is to break that application down into lots of tiny, independent services that all talk to each other. Think of it like building with Legos instead.
And guess what? Java is an absolute beast in the world of microservices. Amazing frameworks like Spring Boot give developers superpowers, making it super easy to create these little independent Lego bricks. And because they're all separate, you can update one, or fix one, or even replace one without knocking over the whole tower. It makes the entire system incredibly flexible and strong.
Okay, so it's king of the cloud, king of modern apps, but what about the really futuristic stuff? We're talking artificial intelligence, machine learning. Surely the new kids on the block own that space, right? Well, not so fast.
Get ready for this, because this number might actually surprise you. Yeah, Python is the top dog in AI, no doubt, but look at Java. A whopping 37% of AI and machine learning developers are using it. It's number 3. That's not just hanging around, that's a major player.
So why? Why is this nearly 30-year-old language still a top choice for something as cutting-edge as AI? Well, it turns out all of its classic strengths are perfectly suited for it. You need extreme performance to chew through massive data sets? Java's got it. You need rock-solid security for a huge company's AI system? Java's famous for it. And its ecosystem has powerful, ready-to-go AI libraries that let data scientists hit the ground running.
So when you put it all together, its past, its present, and its future in things like AI, it really just boils down to 3 core fundamental advantages that explain its incredible staying power. Okay, here they are. The 3 pillars of Java's unstoppable success. Number 1, portability. That write once, run anywhere idea is just as revolutionary today in the world of cloud computing as it was in the 90s. Number 2, its massive ecosystem. There are frameworks and libraries for pretty much anything you can imagine. And number 3, and this is huge for businesses, backward compatibility. It means a company can update to the newest, fastest, most secure version of Java, and their old critical applications, they just keep working. That protects literally billions of dollars in investments.
And that leaves us with one final, pretty deep thought to chew on. Java is so foundational, so baked into the infrastructure of our digital world, from the cloud to our banking systems, that it's become more than just a tool. It's the bedrock. So as technology keeps racing forward, the real question isn't if Java will be a part of the future. The question is, will the future be built with Java, or will it be built on top of it?